Well, surprise, surprise. I actually came across a flat earth debate video, and there was a flat earth guest who was using trigonometry to make calculations to a flat earth horizon. Now, these were only for very low elevations, but it got me thinking because every time we have a photograph, we immediately compare it to the globe model with the curvature calculator. How come we never compare them to the flat earth model? And here is a case in point. This is a photograph from Rampy Flat Earth. It clearly shows wind turbines that are on the horizon. Now those wind turbines are only 30 miles away, but if we calculate this for Rampy's elevation, that horizon should be well over 300 miles away. And if this is the case, Randy might want to submit this because it has just beat the world's record for a long distance photograph. This is the Flat Earth Debate Show. This one is called Flat Earth Diffraction Limit Part 3. There's actually 6 of these that were released last February. The Flat Earther's name is Travis, and he has a YouTube channel called Life is Short. Here is a list of videos from his channel, and you can see there's 6 of them called Angular Resolution in Our World. Now, he's been featured on some other flat earth channels, and I think he's really behind a lot of this nonsense that objects disappear from the bottom up as they get farther away due to the Rayleigh criteria, diffraction, or whatever you want to call it. I haven't looked at all these videos, but what I've looked at, it's a combination of some solid science mixed in with a big dose of pseudoscience. And believe me, some of it is quite convoluted. And this is a prime example of what I'm talking about. You probably recognize this diagram in the upper left-hand corner. It is a Polaris with different lines of sights going to different latitudes on a flat Earth. And I have absolutely no idea as to what he is talking about. I mean, to be honest, this is a case of if you can't dazzle them with brilliance, baffle them with bullshit. And of course, my first question would be, what about trigonometry? Doesn't trigonometry work for these angles, or did it just not give the answer that you were looking for? But here he does correctly use trigonometry. We can see 2 inverted right triangles in the upper left-hand corner here. And what we have is 2 tangent formulas of trigonometry. One of them is height is equal to the distance times the tangent of the angle, and distance is equal to the height divided by the tangent of the angle. And Travis is using the observer height and the distance to the horizon, and the angle is 0.02 degrees. So where did this angle come from? Well, he explains it here. The average angular resolution limit of the human eye is 0.2 to 0.3 degrees, or 1 arc minute. Well, 1 arc minute is 1/60th of a degree, or 0.0167 degrees, and he's just rounded it off to 0.2 degrees. So where does 1 arc minute come from? Well, I'm sure everybody is familiar with the Snellen and eye chart, and typically row 8 is for 20/20 vision. Now, if you look at a letter, we're going to pick the letter E here. Here's how this letter is designed. The height would be 5 arc minutes, and then each segment is 1 arc minute. So, of course, when you read down on the chart, if you can clearly read the letters out, you have 20/20 vision. But if they get blurred, then that would be below your visual acuity. Now I gotta wonder, do flat earthers think that these letters disappear from the bottom up? Now I'm gonna play a clip where Travis correctly explains how these 2 formulas are related to each other. What he's basically gonna say is if a 6-foot object vanishes at 3 miles, then the flat earth horizon is 3 miles away for a 6-foot eye level. So let's take a listen.
So I can do this for any number of distances to solve for height or distance using this theta. And so for height, again, we already mentioned, I lose 4 feet at 2 miles, 6 feet at 3 miles. The corollary to that is for distance, I see 2 miles at 4 foot elevation. I see 3 miles at a 6 foot elevation. I see 4 at 8 and so on. Okay.
So again, what he was saying is first, what is the distance that objects are below their visual resolution, or when do they vanish? So a 4-foot object vanishes at 2 miles, 6-foot object at 3 miles, and an 8-foot object at 4 miles. Of course, the correlator to this was, what is the distance to the horizon for eye level? So at a 4-foot eye level, the horizon is 2 miles away. 6-foot eye level, 3-mile horizon. 8-foot eye level, 4-mile horizon. So let's listen to the Flat Earth debate team and see if they agree with this. We're going to hear Ranty ask a couple of questions, and then we'll hear Nathan.
What does H1? Is H1 height and D is
H1 is height and D is distance. H is in feet and D is in miles.
Okay.
So if I'm at height 1, which is my green guy here, and I move up to height 2, okay, I now see from distance 1 to distance 2. I see further.
Yes. Okay.
According to this angle. Okay. So if I go lower, if I go from H2 down to H1, I see less far. My horizon has been brought inward, assuming I'm seeing with the same arc minute of angular resolution. That's what this formula is saying.
Okay. I understand that. Do you understand that, Nate?
Yeah, it's actually very simple.
So there you have it. Everyone agrees we can estimate the distance to the flat Earth horizon using this formula. Distance equals eye level divided by the tangent of 0.02 degrees. As I said earlier, Life is Short was a guest on some other Flat Earth shows. Here we have Jeranism, again Ranny Flat Earth, Red Pill Philosophy. So the Flat Earth community should be in agreement that this is a valid formula. So let's put this to the test. Here we have a video from Ranny Flat Earth on November 25th, 2018. Now, Ranty was on the top of Nicky Nook, 705 feet. Here we have the Isle of Man in the background and North Perul on the north end. And of course, we can clearly see the Ormonde wind farm is right on the horizon. So when we plug Ranty's elevation into this formula, we get a distance of 382 miles. Now the question is, does this match actual distances from Ranty's location? Well, I went to Google Earth here, and here we have Nicky Nook down here, and this is the latitude and longitude for the center of the Ormonde wind farm, 31 miles away. And if we go to North Perul, that is only 72 miles away. Well, I think it is quite obvious that the actual distance to the horizon is not even close to what it should be if it was on a flat Earth. I even did another calculation with a larger angle of 0.03 degrees, and we still have 255 miles away. So let's take a look at the globe model. I plugged in a distance of 72 miles, a viewer height 705 feet, the refracted horizon 35 miles, the geometric horizon 32.5 miles. Well, again, the globe model is the clear winner here. Now, if the Earth was flat, that horizon should be well beyond the Isle of Man. Now, about 2 weeks ago, I released this video, which clearly shows that the horizon did not rise up to Ranty's eye level. This was another video that he made from Nicky Nook. Now, also in that video, I used this graphic from PhuketWord, and I said that if the Earth was flat, this is what Ranty should have seen. Here we have the wind turbines, we have North Perul, and I showed that the horizon should be well beyond North Perul. And this is exactly what this calculation shows, that the flat Earth horizon would be over 300 miles away, well past North Perul. So again, it is the Flat Earth debate panel that is denying the rules of perspective. Randy's horizon is not over 300 miles away. The horizon did not rise up the Ranto's eye level. Sorry guys, but it's time to wake up and smell the coffee. We live on a globe.